All right, when you're in chemistry class, you're going to be doing a lot of converting from moles to grams, grams to moles, ions, molecules, a lot. So we are going to make sure we can do that in a way that makes sense. So we're going to talk about dimensional analysis. It's just a method of converting from one unit to another. You might actually call it factor label method. It depends on what your teacher likes to use. All right, so we're going to actually do an example rather than explain what it is, because it's actually easier to explain via example rather than just a bold explanation. All right, so the first thing you're going to do when you're converting from one unit to another, in this case 7 days to seconds, we are going to start off with our given. And our given in this case, we're given 7 days. Okay, so we're going to write that down, 7 days. All right, then we're going to write what we call, some teachers call it a picket fence, and this is actually used, and it's quite easy to when you're converting from one thing to another. This method is just the easiest way to organize your data. Okay, so we're going from 7 days, and we want to end up in the unit of seconds. So the things I know that are about days is I know that in one day we have 24 hours. So one day, I'm going to put down here, and 24 hours up here. Now, the reason I put day on the bottom of this ratio, these are equal to each other. They're equal units. 1 day is equal to 24 hours. The reason I put a day on the bottom is because I can, just like I can cross out when I multiply 1/2 and 2/5, I can cross out the numerator and the denominator. I can do that with units as well. So I can cross out day. And so now if I multiply these guys together, I'm actually now in the unit of hours. That's what makes this method so convenient. Okay, but I don't want hours. I want seconds. So I'm going to keep going. In 1 hour, I also know that there are 60 minutes. Okay, so now I have hours on the numerator and hour on the denominator, so I can cross those guys out as well. But again, I don't want minutes. I want seconds, so I got to keep going. So I'm going to say, okay, in 1 minute, I know that there are 60 seconds. Okay, these minutes cross out, and I'm left with seconds, which is exactly what I wanted, so now I can stop. Awesome. So now I can actually multiply all the numerators together and divide by all the denominators, and my answer should be in seconds. Should be the correct answer. So if I multiply 7 times 24 times 60, divided by 1, divided by 1, divided by 1, I get 604,800 seconds. And this makes sense because in 7 days, there are lots of seconds, as we can imagine, and 604,000 is a lot of seconds. So this actually would make a lot of sense. Okay, so this is a method, this is dimensional analysis in a nutshell. Let's do something a little bit harder. Let's say we're changing 2 units, okay? So if you're going 50 miles an hour, how many feet per second are you going? Okay, so we know we're going from miles to feet and from hour to seconds. Okay, so the first thing we're going to do is write down our given. We're going to write down 50 miles per 1 hour. Okay, so here's a conversion that might be helpful for us to continue this problem. All right, so we want to, first thing I'm going to do is change these miles. I want to change the miles to feet. So I know that 5,280 feet equal 1 mile. So I want to put the mile on the bottom because I want to cross these guys out. So I have 1 mile equals 5,280 feet. And cross the miles out. And right now, if I stopped this problem, I would be in feet per hour. But I don't want to be in feet per hour. I want to be feet per second. So I got to figure out how to change those hours. So I'm going to keep going. I don't want to mess with this feet, so I'm just going to deal with the hour. So I know in 1 hour, I have there are 60 minutes. So I can cross out that hour. So if I were to stop now, I'd be in feet per minute. But I don't want it feet per minute. I want it feet per second. So I'm going to keep going. I know in 1 minute, I have 60 seconds. Okay, these minutes then cross out, and now I'm with seconds. So I'm now left with feet up top, which is what I want, and seconds on the bottom, which is what I want. So now I'm in the units that I want. Fantastic. I multiply all the numerators and divide by the denominators. 50 times 5,280 times 1 times 1, divided by 1, divided by 1, divided by 60, divided by 60, is going to give me 73.3 feet per second. Okay, now notice the whole point of this is actually just to make sure our units all cross out and make sure that we're left with the units that we want. All right, let's do something that deals with chemistry. Okay, one question is, how much bleach would you need to make a quart of 5% bleach solution? Okay, so our given is we want a quart of this. We want a quart of this. So I'm going to say our given is 1 quart, and always start with your given. Okay, so I know this unit is 1 quart is 32 ounces. So I'm going to say 1 quart is 32 ounces. Okay, so quart crosses out. And if I were to convert this, I would say how many ounces are in a quart. Okay. Then I want 5% bleach solution. So now the difference is, I'm going to say if I have 1 quart of bleach solution, this is where your units actually can become very important. You're going to get 32 ounces of bleach solution for every 1 quart of bleach solution. Now, I'm going to want 5 ounces of just straight bleach for every 100 ounces of bleach solution. Okay? So that's where this crosses out. So because we know percent means out of 100. So I can actually just do this math and say 1 times 32 times 5 divided by 1 divided by 100 is going to give me 1.6, and my units are ounces of bleach to put in a quart of water to make a 5% bleach solution. This is a type of question you're going to be asked when dealing with chemistry, but dimensional analysis is extremely useful when dealing with your changing of units and going from one unit to another and trying to figure out how to get from one place to another.